Hi everyone, welcome back to my channel. In this video, we are going to cover what are linked lists. So basically, this video is a part of set of videos which are going to be uploaded. This is the very first and the introductory video. So um, what are the contents related to linked list we are going to cover here? We are going to cover what are linked lists. We are going to learn what about them. We are going to get aware of their basic operations, their properties. We are going to cover about insertion and deletion operations and some other complex operations, and we are going to discover how to build and manipulate linked lists. So basically, this is going to be the main focus of the video series. Talking about what are linked lists, so they are basically collection of nodes or components. And what are nodes or components? Nodes or components are basically collection of two things. One is the data. So basically you are creating some data structure, so your target is to put data, right? Store data. So first thing is the main thing, the data or the information you want to store. The second is the link. That link basically contains the position of the memory location of the next node, right? So this is how a linked list is created. So linked list have couple of these nodes. So each node has the data and the position or the link to some other node, right? This is how the linked list is created. The first pointer or a special pointer, which we usually called head or start, contains the position of the very first node. So here you can see that this is the very first node, its position is 2000, and that is stored in the head pointer. Then in single or simple kind of linked list, the next link points to the second. So basically the first link is the first node is going to point to the second node. So basically we have 2800 here. 2800 is the location of the second node, and similarly the third node is going to point to the fourth node. It's containing 1500, which is the position of the fourth node, and so on. The last node of the linked list is going to point to null, right? In the very basic or simple kind of single linked list, we always add a new node at the end of the linked list. So if we talk about the very basic functions of the linked list, these are the few, which includes searching an item in the linked list. So basically you are asked or given an item and you are asked to check that whether that item exists in the linked list or not. Next, the obvious operation, that is inserting something inside the linked list, right? You are given a new data and you are asked to add that or make that a part of the linked list. The third is the deletion. So basically, obviously you are adding some data that is possible, you want to exclude some data from the linked list. So deleting operation is also one of the basic operations. The last one is updating the node value. So basically, let's say you have stored 55 or some node in the linked list, you want to update that to 66, so that can be done. Then all these operations requires traversing the linked list, etc. Okay, so I have divided, I will be covering these basic operations and some advanced operations of the linked list, but I have divided this content to 3 videos. In the very first video, in this video, we are going to cover these 4 things. We are going to learn how to create a particular node, right? How to create one node, then adding that node into the linked list, right? We will learn how to add that at the end of the linked list, and we are going to write a function that is going to traverse the linked list and print all the contents of the linked list. So coming back to the code, the main part of or the main focus of these video series, the first 4 lines are just the including of basic libraries of C++, right? This is the one for printing basically C out, C in, etc. And then I'm including the standard display output namespace. Okay, so nothing fancy here. Talking about the first part, that is, let me zoom it. Right, talking about how to create a node declaration. So basically, as I mentioned, node has two things: info and link, right? So this is how we implemented. We created a structure. That structure has those two things. So structure has the benefit of giving us combining the data structures, right? So we created to a node by creating a structure. That node has one integer value and it's going to have a pointer which is called next, right? And it's going to point to the next node. What kind of pointer it should be? It should be of the node type. Why? Because the next component or the next node you're going to point to is also of similar to the previous one, right? And the previous one, the first node, is actually of structure node type. The second one should also be of that type. So basically, that's why we have created a pointer, which is, this is how to create a pointer in C++. You put a star on the beginning of the variable, right? And what kind of it is of structure node type, right? Talking about this thing, this is basically creating that head or start pointer. And an easy way to do that is to just write it here. This is going to declare a start or head pointer of structure node type, right? Coming towards our main class, the class of linked lists, I am calling it single L list, singly linked list, or single linked list. It has following functions, right? We don't have any private function, right? It is possible if we create some complex data structure, we may need to have those, but currently we are making everything public. Okay, so we are going to cover this thing, which is a helping function. Okay, you need to add a node into, or you need to add some data into linked lists. For that, you first need to create a node, right? And making that a part, and after once you create a node, then only you can make it a part of your linked list. We are going to cover this function in this video, we are going to cover this function in this video, and we're going to cover this function in this video. So starting with the first one. Okay, let's move to this function. Here we are creating the function, creating the node. So this is the code, how we are doing it. Okay, let me explain that. So this is a function that is going to return the node type pointer, right? What it's going to do is it's going to take the value from you, the data from you, then it's going to create a node and return you the pointer or the position of that node. And depending upon which function is calling it, is going to make use of that and making that or adding that to the linked list. Okay, things are going to going to become clear once I'm going to cover the insert last function, but let's just focus on this part of the code first. Okay, so we created two pointers that's called temp and s of node type, right? We say we create a new, we basically allocated some memory for this for node type structure, right? So this is the syntax to create some memory in, allocate some memory in C++. You write new and then you tell the type of the data structure of for which you want to allocate the memory. For in our case, that is node type. Then we say if node is equal to null. So obviously, if this is not going to work correctly, only then it's going to have null, else it's going to have the pointer to that memory, right? So if it's equal to null, we say sorry, memory is not allocated, and we return 0. Return 0 means kill the function, kill the program. Okay, end it. Else, if that thing works properly, this would happen if your memory you run out of memory only, right? Or there is some hardware failure or something. Okay, so what we do then? We said okay, memory is allocated for us, it is of node type, right? We point, we put its information equal to value, right? That is what we want. Okay, so this is how to do it. So if you want to set the variable inside this temp info variable, you do this, you write this pointer notation, you equal that to value, then you put its its pointer to null. Okay, so a new node will be created, something like this will be created, value will be put here, and this link would be pointing to null. And then you return temp, that is going to return the pointer temp. Coming towards insert last function, okay, which is making use of this function. It says it's not returning anything, right? What it's going to do is you are going to, if you want to create, add element or information at the end, you're going to make use of this function. Okay, Okay, so it says give me, okay, it's first declare a value. Once you call it, that would be basically in the main function we are having this case structure, right? It's going to ask you what you want to do. If you want to insert in the last, you give 2, right? And this function is called. So once this function is called, it's going to ask you to enter the value you want to insert. It's going to see in that, it's going to input that, and then it's going to do two things. Creates two variables, the temp and the s type. Then it calls the create node function. So now it doesn't have to manually handle creation of the node and then putting the value to that node and then let putting its end pointer or its link to null. Okay, you simply pass the value here, you will be get the node implemented, and then this temp is going to point to that node. Okay, you say s is equals to start. Now why this is important? Okay, as I mentioned previously that in linked lists, in typical linked list we only add the node at the end, right? So you don't have a pointer pointing to the end, right? You have a pointer that is pointing to the start of the linked list. Now you need to find the location, or you need to reach the pointer of the end node. What you do for that? You keep s as equals to next, you put a while loop, and then you say keep on traversing, hopping to the nodes until unless you reach a your until unless your next pointer, basically the pointer of the node you are pointing, is equals to null, right? So that is going to be the pointer of the node that is in the end, right? So you keep on increasing or incrementing the value of s to the very next node. Okay, in the start it is the start node. Okay, okay, so okay, so then you, once you reach here, that means now s is pointing to the last node, right? You put the temp next equals to null. If even if you have not done that, this would already been done in this function, right? But still that is repeated here. And then you say s next is equals to temp. So basically s is now after this loop pointing to the last node, and then we want its next to point to the newer node we just recently created. That is going to be done here, and once that's done, we would say the node is implemented, the node is made the part of the linked list. Coming towards the display function, that is very easy. That's is simply having a mechanism we have already covered. Here it is. So what we do here, there's a display function. We say, let's talk about this first. We say if the start is equals to null, linked list is empty. Sorry sir, it's empty. Talking about now, that again, that traversing mechanism is exactly same. We created a pointer, put that equal to start, and then we keep on traversing it until unless we reach not the next one, we reach null. So we keep on printing the value of the information of the node temp is pointing to, and after doing that we move to the next node, and once we will reach null, that means entire linked list is completed. Okay, so these are the three functions we have covered in this video. Let's